Hi, my name is Ryan Alcantara. I'm from the University of Colorado, and today I'm going to talk about loading asymmetry before and after a freshman collegiate runner sustains a metatarsal stress fracture. What you need to know is that 23% of stress fractures that are sustained by collegiate runners occur in the metatarsals, and these are painful injuries that take months to recover from. We decided to look at two external loading variables that have been associated with running-related injuries, and wanted to monitor the changes in these variables for each leg over the course of this individual's freshman year. Here we have a typical vertical ground reaction force trace for this participant who is a traditional forefoot striker. And we decided to look at loading rate, which is the slope of that vertical ground reaction force signal early in stance phase, and peak vertical ground reaction force. Now, I said this is a longitudinal study, so we monitored them 3 times during the freshman year. We brought them in the fall during cross-country season, during the winter, which is indoor track season, and then in the spring, which was outdoor track season. And the injury was sustained in between indoor and outdoor track. So if we treat injury as of day 0, our data collections occurred 20 weeks prior, 3 weeks prior, and 11 weeks after injury when the athlete was cleared to return to practice. We brought them in and had them run our instrumented treadmill for each of these collections. So now this timeline becomes the x-axis of this plot, with the y-axis being loading rate. Red represents the values for the injured leg, blue is for the uninjured leg, and the violin plot shows the distribution or the variability between steps, since we were able to collect multiple steps from each collection. 20 weeks prior to injury, there was a 2.8% difference between loading rate between the injured and uninjured leg. That increases to 6.2% 3 weeks prior to injury, but then it increases again to 8.2% after they've recovered and returned to practice. Additionally, there's kind of a positive slope over time. So this isn't exactly what we would expect, considering that prior research has used loading rate to identify running-related injuries prospectively. For peak vertical ground reaction force, we see a 2.2% difference between legs at 20 weeks prior. That increases to 3.7% right before injury, and then after they've recovered, the difference decreases to 0.6%. This is a little bit more in line with what we'd expect if we wanted to find a variable that would change prior to injury, leading up to injury, and then return to some baseline or normative value. Additionally, if we look at the distribution of the variability between steps, 20 weeks prior and 11 weeks after injury for peak vertical ground reaction force, the distribution is very similar, but right before injury, the distribution between steps changes pretty drastically. This pilot study suggests that we might need to be looking at leg-specific variables when it comes to injury, instead of averaging between legs. But there's more work that needs to be done to identify clinical thresholds as far as what's clinically relevant in terms of percent differences between legs. I want to thank the University of Colorado for their support, as well as the Pac-12 Student Athlete Health and Wellbeing Program for funding the study.